Good. So we can start with the overview, let's say the talk, and then take a small break for a coffee and then do the practical. The two things are really connected and we can blend one into the other. So
should I mention the practical? That
yeah.
Like the practical is available if people want to start toying with it?
Oh yeah. I was about to show the resources. So in terms of material, the slides are already shared in the Discord channel, but they are also available online. I will share my screen, and basically there are a couple of websites that are also in the Discord channel. So one is the GitHub repository. So the approach for the Nextflow tutorial is trying to make a pipeline rather than seeing all the steps and all the bits of syntax, because that would take really a long time. Nextflow can be a bit complicated. So the goal would be to demystify the process. And the whole code is on GitHub, and it's also broken down in step by step. So there is assembly 0, 1, 2, 3. You can see the script growing. And there is also sort of a handout here that is linked in the repository and is also available in Discord. And that's sort of a narrative view on why we need the Nextflow and what are we doing with this pipeline. So you will see that in practice, everything you learned or you refreshed this morning is going to be glued together in Nextflow. Containers are built in. Conda is also built in and very useful. So there are a lot of things that will blend together. So let's start. I saw also with the small poll that I made that most of you never heard of Nextflow, which is both good and interesting. So as I said, the program is we continue the journey through the modern bioinformatician toolkit. We will use containers. So those are sort of a prerequisite to make good Nextflow workflows. And at the same time, this is sort of a competitor or an alternative to SnakeMake. They're both really good tools and also very widely adopted, both of them. And so you will see that some concepts are recurrent and others are completely different. I mean, some philosophical decisions were completely different, but in practice, we will see what Nextflow is, and why we should really start to use Nextflow more, even for smaller pipelines, because when we have a task that we do more than once, it's going probably to become a pipeline. And there is a point where everything breaks and we need to start from scratch. So if we start with a system that is assisting us and is able to scale up, we'll probably save some time in the long run. Also, there are a lot of batteries built in. So for free, we get a lot of tools to make better work.
Andrea, are you, sorry to interrupt, is your slide supposed to be full screen, or are we meant to see half your desktop as well?
Well, it's a problem of aspect ratio. I have a very wide monitor, so
oh, okay, just so that, I mean, there's nothing untowards on, so it doesn't matter, but just wondering. Okay, that's fine. I mean, I can read it fine. So
it was also to swap with the terminal with these in case.
But, okay, no. Okay, fair enough.
Can you see the slides?
Yeah, I can see the slides. They look good.
Can you read them? That's what.
Yeah, I can read them.
That's the important part. Thanks for the feedback.
Yeah.
Okay. So in terms of goals, as Nabil already mentioned this morning, Nextflow is quite complicated. So don't think that after a 30-minute tutorial, you can start writing workflow independently. But I really hope that you will see all of the patterns that recur in the typical workflow, and you will be interested in knowing more. So from the very, let's say, the easiest goal would be to be interested in seeing if there are workflows available for what you do written in Nextflow, and you become sort of a Nextflow end user using other programmers' workflows. And hopefully a fraction of you will be also interested in trying to make their own workflows. So the workflow that I picked as a model is the de novo assembly of bacterial genomes. And I also used the shovel for the assembly. But of course, this is just a prototype. It's just a way to take an example. So this is our minimal workflow. We have a directory with a lot of samples that have been sequenced. In this example, we'll use paired end Illumina files. Then we have some steps. A workflow is a set of steps that are interconnected. So we first filter the reads based on their quality. Then we perform the de novo assembly. And these two steps are in a one-on-one relationship with the input. So every input files need to be filtered and assembled. Then we can go further and do the annotation with Proca, for example. And again, one-on-one, every config file needs to be annotated. But there are some times where our workflow needs to collect all the outputs from previous steps. For example, there is a program called Quost that will summarize the assembly metrics for all the assemblies. So when all the assemblies are available, we collect them in another process and we run Quost to generate a report. This is the, let's say, one of the intermediate stage of the pipeline that we are going to build. It looks like this. And it's already usable, and it's already producing some output, and it's already giving us some benefits that we will see. Then we can complicate a bit the pipeline a bit more. We can add abricate to predict the AMR genes, and also abricate as a step where it can summarize the findings across some multiple data sets. So we run abricate for all the samples, and then we collect all the predictions and we create a summary. And there are two things that this extended workflow adds. One is a fantastic tool that is called MultiQC. And if you don't know about it, this is really something that it's worth the talk. MultiQC.info is the website, and it's a program developed to create reports like this one, where you can have a lot of sections, one for each tool that you want to summarize the findings from. And basically, it's supporting natively a lot of tools. For example, FastP, Quost, and Proca are natively supported, so you don't need to do anything, and MultiQC will generate the report. But for example, abricate is not. So we can write a custom script in Python that converts the summary into something that is MultiQC friendly. The script is already in the repository, of course, but the point is, Nextflow makes it easy to expose custom scripts to your workflow. And also MultiQC is getting inputs from a lot of branches of the workflow. So this is also something that is a common pattern in some typical pipelines. We're not going to reinvent the wheel. You will see later with Robert, that is the author of Bactopia, that is a fantastic pipeline for the Nova assembly that bundles 100 tools or something like that. And coincidentally, is also written with Nextflow behind the scenes. But unlike other workflows, it's really well, Nextflow is really well hidden from the user. So if you don't know anything about Nextflow, you can still run Bactopia, while it's not the case for a lot of other workflows that you will find around. So the information that we will gather today, they will help you to run other workflows as well that are less user-friendly. So what is Nextflow? You saw SnakeMake, and Nextflow is a similar system. So it's two things. It's a language. It's a language that allows us to define the workflow. So once we have our set of blocks and arrows, we can convert that to a script, to a Nextflow script, because the language allows us to describe the interactions within the blocks of our workflow. And it's also a runtime environment. That means that it can take the script and orchestrate all the jobs in an efficient way. So if you have a single computer with 16 CPUs, it can send different tasks to different CPUs. Or if you have an HPC with a lot of blades and nodes, you can send jobs, and it's supporting very well Slurm, OpenPBS, and other schedulers. And again, if you want to scale up even further, it's supporting very well also the cloud and cloud computing environments. So Amazon Web Services, Google Cloud, Azure from Microsoft. So there is a lot of things behind the single Nextflow script. And this means also that we can separate two things that sometimes makes our script not very portable. So one is the logic of the workflow. There is the main script with the blocks and their interconnections. And the other is the configuration. So for example, if your local HPC has a set of specific queues for the scheduler, for example, QAB long or QAB high memory, something like that, you can specify when to use each queue for your jobs. And the good thing is that once you create your, for example, HPC configuration, you can use it with all the Nextflow pipelines that you are going to run in the same premises. But it's important to highlight that you have two sides to code, both the logic and the configuration. And the very good thing is that most of the times they are separate. And now a big warning, if you want to start learning Nextflow, for some years it has been around with a syntax called DSL1. DSL means domain specific language. And now the second version is mature, and it's completely different and offers a lot of advantages. But when you Google for help, you will need to specify that you're interested in one of the two. And I recommend you that you should start with DSL2. And also when you find tutorials, check what they are dealing with, because it can be confusing at the moment because there is sort of this transition happening. But DSL2 now is mature and offers modularity and code reuse. So with DSL1, you had to write a massive script. And now you can use different files. And so you can have the shovel module and reuse it every time you need the shovel, for example. So it's really good. Some core concepts, and those are not completely dissimilar from what you saw with SnakeMake. So what is a SnakeMake rule in Nextflow is a process. And in the process, you define, similar to the rule, which are their inputs, which are the outputs, and the script, the actual commands. Something that is quite special are the channels. So the pipes that you use to connect the processes together are called channels, and they are queues of files or data or values. And Nextflow is really efficient in deciding when a process needs to start. So for example, you will see later that Nextflow works in a slightly different mode if compared with the scripts that we are usually used to, and this is very good. Finally, a set of processes and channels is called a workflow. Now, I mentioned most of the benefits, and I would like to highlight a couple of more things. So versioning is built in. As you know, GitHub or any Git repository allows you to keep track of code changes. And this is good because if you want to rerun a pipeline you ran 1 year ago, you don't want to run it with the code that has been evolved ever since. So you can say, well, let's pick up a version 1.2 or this particular commit that was used last year. And Nextflow really works well with repositories. And in the end, you can create your pipeline, store it in a GitHub repository, and any machine can run the same pipeline without needing to install it, because Nextflow can take the code from the repository for you, from the configuration file, can understand if there are containers or Conda environments to be created, and will do everything for you as well. So with a single command, you can have a new machine, a new client VM, for example, and run the workflow immediately. Also, there is a fantastic community, and you will see more about that in Robert's talk later. Now, as I mentioned, the logic is not the only thing. So also the configuration is important. And also configuration can be quite hard at the beginning, especially because it's layers. So the workflow will carry some configuration files, let's say workflow specific, but then there will be something that is your machine configuration. For example, you can tell how to use Slurm in your computer, in your cluster, and you might have some user preferences, so something that only applies to you and not to your colleagues. So you should be aware that sometimes the configuration can change because of all these layers being applied to the workflow. But in the end, this is also, as I said, quite a good thing, because just reusing the same configuration file can allow all the workflows to run in a new computer, for example. Let's start with an overview. So we have our de novo pipeline, and now we want to start to build it. And I will start from the end, so from the whole workflow. This is the workflow, and I wanted to put it in a slide because I think that one of the advantages of Nextflow is that the syntax is quite clear. So even if you don't know what's happening, you can understand the logic. So this gray part is written here. The workflow starts with, well, the workflow doesn't start with the first command. This is not a procedural scripting. This is asynchronous. So what Nextflow will do is checking what channels are available to start. So reads is the input channel that we will see how to create. And so the only module that can be spawned is FastP. But for example, when the assembly is done, there are multiple modules that are using the output of the assembly. So both AMR and Proca are using the assembly output. They will run simultaneously. There is no need to wait for AMR to finish to start Proca because they are using the same files. And at the same time, if we have 10 samples, if one sample is very small and it's going to be the first to be assembled, then its AMR and Proca modules will start before that, for example, FastP of the largest sample has even finished. And so more or less, this is the syntax. You have every process and then the input parameters of the process in brackets. And in this case, we start with the reads, and then the process itself with .out allows us to pick the output of the process. So the output of FastP will be the input of assembly. The output of assembly will be the input of AMR and Proca. And sometimes we need to use some different patterns. For example, we said that the Quast will collect all the contigs. So we don't want a one-on-one execution. We want to collect all the contigs that have been generated in the whole workflow and feed them to a single Quast execution. So in this case, there is this .collect method that we use multiple times. And sometimes we want to tweak it a bit. So this means that the output of the assembly step is actually a tuple, let's say a dictionary where you have the sample ID as a key, and then also the actual file. We only want the file, we don't want to keep the value. So we are mapping, basically we are collapsing the tuple and just keeping the files. This is one of the technicalities that requires more knowledge, of course, of Nextflow. And another operator that we are seeing here is mix. So for multi-QC, that I said is a common way to end a workflow. We need multiple output from multiple blocks. So we are mixing FastP out with Quast, Proca, Abricate. And with collect, again, we say it's not a one-on-one execution. We want all the outputs in the same process. And this is just to clarify how simple can be and how expressive can be the workflow. Now let's see how do we write a single process. Again, it's quite simple. It's not very dissimilar to snake-make rule. We have the input part, the output part, and the script part. So every line in the input is one input channel. So if we have only one input arrow coming into our block, then we have just one line. Same for the output. In this case, we only have one. And as I said, sometimes we want to propagate both the files and some metadata. In this case, just the sample ID. So we use the tuple, where we have this pair of sample ID, this is a value, and then a file that are the reads. There is a special channel for paired and reads. So in this case, our pipeline will be written for paired and reads, and you will see this because we are going to use it as an array where reads 0 is the forward pair and reads 1 is the reverse pair. Sometimes we have some variables that you will see emerging in our scripts. For example, task.cpus is the amount of cores that we want to dedicate to that task. And here we don't just specify how many, because this will be something that the configuration allows us to tune according to the capacity that we have. In this case, we have two output channels. So we want to propagate both the context and the log. And to make it easier to pick it up, we just name the channels. So this will be CTGs and this is log. And you saw this use of named channels here. So fastp has two channels as output, the reads. So fastp.out.reads. And the other is JSON, fastp.out.json. JSON is the file where we store the metrics to make the report, while the reads are the cleaned reads. So of course, assembly will use the cleaned reads, and MultiQC will use the JSON file, let's say the log. So something that is very simple with DSL with Nextflow in general is that every pipeline requires some parameters from the user. For example, you wrote --r1 and --r2 to talk to Showville. Those are easily created with params.something. So if I want to receive a variable called a parameter called reads from the user, so --reads, that will be passed inside my script as params.reads. It's a good idea to initialize it either with a default value or with false, just to say that we are going to expect this parameter. And this special pattern is the way that Nextflow creates a paired end channel from files. So we specify star. So all the files that have _r and then either 1 or 2 and bioinfoskills.gz. The key part is that you need the star to specify all the files. So everything that is captured with the wildcard star will be the sample ID. And then you need a pattern that allow you to identify a file as forward or reverse. This can be 1 and 2 in Illumina, or F and R if you have different inputs, or you might need to remove the R. But the point is, you need two patterns, one for the forward and one for the reverse. The first will be reads 0, and the second will be reads 1, for example. So this is just a parameter. It's a string that the user feed to the program with this command. You will create a channel starting from that pattern. So we'll say create a channel from file pairs, and this statement is going to fail if the file are not found. It's a good idea to check before starting the workflow. In general, we have a lot of channels created. So reads is the one that we just created manually from a parameter, but then fastp out.reads is also a channel that is the output channel of fastp. And sometimes we are confused because, for example, if I forget that AMR out is a tuple, for example, I might get weird results. We have this operator .view to print to the console the content of a channel. So for debugging and learning purposes, it's good to try .view sometimes that can be also chained with other operators. And this is probably the take-home message here. If you have a question, how do these works in Nextflow? The idea is just try creating a small script with 3 lines, make your own channel, and then try to manipulate it and see what happens, because it's probably the easiest way to answer your first questions. If I must say, one limitation of Nextflow DSL2 at the moment is that the errors, when you have a syntax error, they are not very clear yet. They are probably going to be improved in the future, but sometimes you say you get an error that is unexpected characters in this line, and the problem is in a completely different position. So this is something that I'm sure it will improve. I see something from another user that had probably the same problems they had. Okay, so I'm finished with the introduction, but I want to just give an overview of what we're going to do after the coffee break. And I'm sure that you need a coffee as much as I do. So our idea is that we are going to build the pipeline. But before building it, this is part of the fantastic benefits of Nextflow. If you are able to pull images from Docker and you're not run out of your capacity for the day, you can have a new machine like yours. You can have a directory with some reads, for example, data slot and some reads there. And with this command, you say Nextflow run. This is the name of a repository. So in the pink part, you can either specify a file that you have in your system. Maybe you downloaded a Nextflow workflow from GitHub, and so you have a local file. But if you don't have it locally, you can just say username / repository name. And if it's a Nextflow repository, it will be fetched automatically. And because versioning is important, you must specify which version. So with -R, you can specify either the branch, for example, main, or as I suggest, a tag like 1.0, or you will check in the repository what are the versions and tags available. Again, this ensures reproducibility because, of course, main will change over the time. And then, because the repository that I set up has a configuration that allows you to use Docker, it will pull the Docker image to run the workflow for you. So you don't need to install anything, and everything will happen magically. And you will see how easy it is to run a pipeline once you have once you have shared it publicly with GitHub. So this is already a very nice start, seeing how this can work. And I made a couple of screencasts, so you don't need to actually run the code. You can see how it works. When you run the pipeline, this is the visual feedback. You have all the processes already written here. And as long as they start doing something, they will populate. And so here is FOSP working, 0 of 3 are completed. And when you finish, they are all completed, of course. But you will see also these strange strings here. Now, FOSP will run as many times as your samples are. So you will see only the last execution here. But basically, this is the way Nextflow makes the pipeline development and debugging much easier. So every single process is executed in a contained directory. This means that, for example, by default, it will create a work directory. And in the work directory, we find B3 and then E61 something. And if you list the files there, you will see that Nextflow first creates symbolic links to the input. Then we create the bash script with the command to be executed. Then we'll store the log files there. And then if some output files are created, you will find them here. If something goes wrong, you can just cd into that directory and try to run .command.sh, see what happens, see what needs to be fixed. And it's, as you can see, if compared with the typical workflow where you have a lot of files being written, here it's much easier to debug because it's a contained execution. So we need to get the parameters. We need to write our first processes. And this is the visual representation of .collect that after we process some samples, we need sometimes to collect all the samples and make a process that make use of all of them. And yeah, I can only say that I really reckon that Nextflow can be hard, but I think that the amount of satisfaction that it can give quite balance the effort required. So I hope that some of you will agree with me at the end of the practical after the coffee break. So if there are any questions, feel free to fire now. And